Hello guys. In the previous modules of this course we have learned about entities and the relationship that can exist between them. We also see how it is possible to model these relationships logically by using entity relationship diagram ERD. And then we learned how to normalize a design to obtain the optimal level of data redundancy. Now in this module we need to learn how to implement table relationship in SQL Server. And just a quick reminder, you remember when we had provide a sample data for our course, and in our sample data we had created a diagram in database diagram, and in database diagram now we can see the relationship between all these tables. The relationship is between, of course, the keys. Here we have a relationship between a primary key, and here we can consider this one as a foreign key. In some relations, sometimes you have a primary key to be linked to another primary key. It depends on what scenario, and the data is supposed to be fixed, not repeated data in the tables, or you will allow to have one-to-many relationship, and in that case, with that many relationship, you can have different data on the other side. And also we have the foreign key, which we had explained before. What is it? So now let us talk in more details about these relationships. Our main goal now is two main topics. The first one, we need to understand how we can implement various types of relationships in SQL Server database. And then we need to describe the considerations for planning referential integrity in SQL Server database. So now for the first part, we need to see what kind of relationships do we have. Definitely, we already explained one-to-one relationship, one-to-many relationships, and many-to-many relationships. And we understand all these three. But in addition to that, we have some additional subjects to talk about. So later in the practical side, we won't have any problem to implement any one of these. Okay, let us start with the referential integrity. I need to remind you, in ERD diagram, we specify the relationship that exists between the attributes and entities. In a relational database, we need to implement entities as tables, attributes as columns, and implement relationship by forcing referential integrity. So let us jump now again to the sample data. We have it on the server, just to talk a bit about it. And by this, you're not going to forget what is this referential integrity. Now, again, here we have the tables and we have the attributes. The attributes here, these values, later they are going to be converted into columns, right? And the referential integrity is to maintain the relationship between the attributes in different tables. So the meaning of referential integrity is to ensure the value in one attribute have corresponding values in second attributes. This ensures that the data remains meaningful. Now let us quickly discuss this example. Assume that in these two tables, I have order ID, customer ID, store ID, but staff ID here is null. So what is the benefit now of a staff table? And what is the benefit of this relationship? If I don't have a value of a staff ID in this table, I won't be able to access to the information of the staff. So that's why it is important to implement this referential integrity to make sure whenever you have a value in the order table, then there is a corresponding value in the staff. So you'll be able to link the two values and extract the information relating to this order. The next point is, or the next subject is one-to-many relationship. Now with the one-to-many relationship, we already explained it before, and this is now just a simple code to show you how you can create one-to-many relationships. For now, we are going to skip it because later, anyway, we are going to implement both methods. By using a graphical user interface, we will see how to build everything from scratch and how to create a relationship between different tables. And also we apply some of these relationships by using code. So here the code usually is like this. As you see, you have a create table, and then you start to configure some of the attributes or columns, values. And finally, you are going to build a constraint key and define it as a primary key. And here, that key also, you can link it to another table as we see in this example. Here the reference is customers, which is this table. So by this now I link both tables together. For now, don't bother yourself because later, once we explain it in practical, it's going to be very clear without any problem. Here just show you the code how it look like. Now here also we have another point which is optional or required, and I mean by it with some attributes we can allow null value and with some others we want. So for the required relationship we are not going to allow any nulls in foreign key columns. Optional relationship allow nulls in foreign key. Here, as you see with this definition, I don't allow a null requirement in some of the fields. In some others, no, you can have null value. If I jump back to our example, we have it previously. Here, when we try to create now another table for the serial number of the laptop and link it to the employee who might has a laptop. What if the employee has no laptop? So in that case, this relationship is supposed to allow null values because we might have no laptop at all for this employee. So in some scenarios, null value in relationship might be allowed. Another type is one-to-one relationship, and with this one is when there is a single relationship between those tables. I will assume we create a table for child and we want to link it with his parent. So in that case, definitely this child has one father and one mother. So it is going to be from the child side one-to-one relationship, but from the father side it might be one-to-many relationship because the father can has more than one child. Now one-to-one relationship also it can be mandatory. Imagine that a man who is not married and he has no child. So in that case, we can create a foreign key in either table. And if the relationship is optional in that case, because the man has no child, then we should create a foreign key inside of the relationship that allow nulls. Another subject is many-to-many relationship. With this one, we can implement relationship many-to-many by using an intersection table. As we see in this table, here we link the employee ID to phone number ID, and the phone number ID is being linked in another table to a phone number. Of course, later you can run a query. The query for this employee ID is going to find all the joins between all the tables and retrieve back finally for employee ID 1. His phone number is this one. Another definition for relationship, which is supertypes and subtypes. With this one, assume the following scenario. We have an employer who has two skills. So that's why his employee ID is going to appear in two different tables for the sales people and technicians. This kind of design, we call it supertype and subtypes. A supertype information is going to appear in a subtype tables. Another point is self-referencing relationship. It occurs when a one-to-many or one-to-one relationship exists within a single table. For example, imagine an employee table that includes the columns employee ID and the manager ID. The manager ID columns indicates the employee ID of the manager for any given employee. The values in the manager ID column are a subset of value in the employee ID column. To maintain now referential integrity between the columns, you must create a foreign key on the manager ID columns that references the employee ID column. And a self-referencing relationship might be optional or it might be required. So if it is optional, a null value will be allowed. So as we see now, the referential integrity is the main key element to implement the integrity of relationship between tables. And we have two options to implement referential integrity. The first one is declarative and the second one is procedural. With the first method, we need to use foreign key constraint, and that is going to maintain the integrity. So for example, if a transact SQL statement attempts to insert a new row into a table, any foreign key constraint on that table will check the new data values in the statement against the referenced columns. Of course, to ensure that they are valid before inserting the new row. With the second method, instead of using the foreign key, we need to use a trigger. A trigger itself, it has a code of transact SQL, and according to that trigger, we can determine if this change will be allowed or not. Now, finally, if we need to push the update of referential integrity, then we need to use a cascading. We already implemented that before, I'll show you, but we hadn't explained it. When we try to inject our system with sample data, then through the creation, we have here update cascade as you see in here with the foreign keys. But we hadn't explained it later. We need to build something similar and we need to go through the code line by line to understand it. And also we will use a graphical user interface to achieve some of the work. So by this, we will gain enough experience by using GUI and by using command lines. So with the cascade, the idea is simple. When you try now to modify a value of a key in one of the table, like here in this table, which is the customer ID table, we just update the value from B to Z. Then automatically the system is going to update cascade to order table. So now the value which it was before B becomes it now. And by this we will keep the integrity of all the keys in all tables. So that's all what we have it with the relationship. I know we need to show how we can do all of that in practice, and this is what we need to do next. Thanks for watching.